Hello and welcome to this higher tier GCSE lesson on the difference of two squares. Firstly, you're going to complete the do now task and factorise these four quadratic expressions. Write down the question as well as the answer. Pause the video while you work through them. Okay, let's mark the answers then. So the first one, we should have x plus 6 and x plus 2. Remember from last time, the order of the brackets doesn't matter, so we could have had x plus 2, then x plus 6. The second one, we should have x take away 6 and x plus 1. The third one, x take away 2 and x take away 5. And the last one, it's given you a hint because it's written in a different format, or it looks different. So if we think of this as x squared plus 0x take away 9, then we are thinking of two numbers that add to make 0 and multiply to make negative 9. So this gives us x plus 3 and x take away 3. Okay, so as we mentioned last time, we're going to be looking at the difference of two squares. This is factorising for a specific type of quadratic expression. So a couple of topics ago, we expanded the brackets for things like this. So you can see the example in the middle of the screen, x take away 7 and x plus 7. So whichever method you use for expanding, you would end up with x squared take away 7x plus 7x take away 49. And those two terms in the middle cancelled out, the take away 7x and the plus 7x. So we're left with x squared take away 49. So we're going to be doing the reverse of this. So you can see some brief examples there. We'll go through those in more detail later on. For the difference of two squares to work for this method, first of all, there are three conditions. So there must be two terms, they must be separated by a negative sign, and each term must be a perfect square, meaning it's something you can work out the square root of. So when these three conditions are met, this is the factorisation. This is the general rule for the difference of two squares. Copy the general rule into your exercise books. So looking at an example, we've got x squared take away 9. We can see that both of these terms are squared. So we will have x add 3 and x take away 3. If you want to expand the brackets to check that you get that quadratic expansion when simplified, then you can do. Next example, copy this one down as well. So here, everything we can see is something that is squared. So the 9 is 3 squared, the x squared is the square of x, and 169 is the square of 13. So we can see there that we've got 3x squared and 13 squared as our two terms. So in the brackets, it becomes 3x plus 13 and 3x take away 13. Have a go at these ones. Write down the question as well as the factorisation. Pause the video while you work through them. Okay, let's check the answers. Okay, mark your work and pause the video while you check them. Here's a problem-solving question for you to have a go at. Pause the video while you work through this. Okay, let's mark that question then. Okay, building on from what we've looked at before, we've done part A. So we know that x squared take away 9 is x plus 3, x take away 3. Now looking at part B, it says use your answer to find the two prime factors of 4,891. The first thing we are going to do is start with the quadratic and set that equal to 4,891. And then if we solve this by adding 9 and then taking the square root, we get x is 70. X could also be negative 70, but that's not going to be appropriate for the topic we are on when we're looking for prime factors. So when x is 70, using the brackets, the factorised form, x plus 3 and x take away 3, we're going to have 70 plus 3 and 70 take away 3. And therefore we have 73 and 67 as the two prime factors. Okay, have a go at these questions. Pause the video while you work through them. Do make sure you write down the question and your working. Okay, let's mark these. Right, we have done the majority of this chapter now. So we have factorised almost everything. We've got one more format to look at. And you can see at the bottom that is of the format ax squared plus bx plus c. And we have rearranging simple formulae. So I will see you next time for that final factorising topic. Goodbye.